So we're now going to talk about ways to visualize this particular case study. And I'm a big fan of visualization because looking at code will only show you a piece of the puzzle. It's very static, but a visualization can give you a sense of the dynamic behavior. So we're going to take a look at how this actually performs when you would run it in practice. So the app is based, the version of the app we're going to look at here is based on parallel streams using blocking I/O. What does that mean? It means if you want to download an image, then a thread in the thread pool will be selected. It will go ahead and essentially open a socket to the server, and it will then block until all the content has been downloaded and the result comes back. So that will be in contrast to other versions we'll look at later that use asynchronous computation, things like completable futures. So what we're going to do here is we're going to get a list of URLs. We're going to ignore any images that we've already downloaded and cached. So there's a cool little caching technique we use here, mostly just to motivate the use for filter. We're then going to download non-cached images. So if an image has not been downloaded before, we'll then go ahead and download it, blocking along the way if necessary. We're then going to apply a list of filters to each image. So if we had n images originally, and we were going to apply m filters to each image, we would end up with n times m number of filtered or transformed images. Once again, very much like your assignment 2 app or the assignments you've been doing, the web crawler, image crawler app. And then the final thing we do here is we store the filtered images into the local file system. So they are on the device, and then we go ahead and display the images to the user by popping up a GUI that you can browse and play with. Assuming you're using the Android version. If you're not using the Android version, they just reside in the local file system, and you could use some other viewer tool to look at what the images were. What I want you to appreciate at this point is how the use of declarative mechanisms in Java streams maps pretty much one-to-one onto the domain intent that forms the description of what the program was doing. So as you're going to see here, we're going to essentially ignore cached images, right? So we're going to filter out images that are already there. We're going to ignore them. We're then going to download the non-cached images. We're then going to apply the filters to each image, and then we're going to store them in the file system. The mapping, the filtering application and the storing applies at the same point. I could have split them apart if I'd wanted to, but in this particular case, I combined them. And then there's also, of course, the reduce, stream, concat stuff lurking here, which I don't show. And then finally, we go ahead and collect everything into a list that is then displayed to the user. So the key thing to note here is by using functional programming features for the computations, we're able to show a nice alignment between the domain intent, namely what we're doing on the left, with the actual computations, which is carrying out the work on the right. And that's a really nice property of using these higher level abstractions, because you don't get lost in the details of a lot of imperative code with loops and if-else statements and so on. So this is basically how things work if you want to kind of break it down step by step. So we start out with a list of image URLs, which we got from a user or from a file or whatnot. We then convert that list into a parallel stream by using the parallel stream factory method. That then creates us a stream of URLs. We then go ahead and take the stream of URLs and input it into the next phase in our pipeline, which is the filter intermediate operation. And what filter is going to do is it's going to ignore images that are already cached. So if an image is already cached, we're going to ignore it. And that's going to output a stream of non-cached image URLs, so there could be fewer than we came in with. We're then going to have that input into the map intermediate operation, and we're going to perform a blocking download. So for each of the images that was not cached, we're then going to go ahead and block while downloading them using the threads in our pool, which is the resource pool pattern we talked about before. Oh, and of course, this whole thing is the pipes and filters pattern that we talked about before as well. Then we'll then end up with an output stream of downloaded images, and then those get fed into the map operation again, where we're going to apply the filters to each image. That will return a stream of streams of these filtered images, which we then would use with reduce and stream concat to turn into a stream of transformed images, which we then go ahead and connect into collect, and we end up triggering all the intermediate processing, because nothing did anything until we reached this step, of course. And at that point, we then store the results into this list, which can then be displayed. And what's neat about this, and really, again, just underscoring probably for the umpteenth time, the power of the Java Streams framework to orchestrate all these steps, and not only orchestrate all these steps, but orchestrate all these steps to run in parallel, which is remarkably easy to do once you understand the programming composition techniques of streams, which allows for functional composition.